So let's talk about pieces. Linguistics and philosophers often think of sentences as being either true or false. It's just part of their meanings. But what about the bits and pieces that make the sentences up? Words like all or some, or phrases like lives in LA or help the helpless. Our success in finding out how the true or false they can be is predicated on donning our logic hats and doing a little investigating. We talk about how it was first developed by the Greek thinker Aristotle to get a better handle on why some kinds of arguments were convincing while others weren't. We also learned that philosophers developed sensual logic as a way of expanding on what that original system could do. Aristotle's approach couldn't really deal with complex sentences, and it didn't really have a good way of talking about individuals, only groups. So the artificial language of sensual logic was designed to use the letters of the alphabet to stand in for any of the sentences you can find in natural language. Take a pair of sentences like the powers that be sent Cordelia a vision, she received it. We could symbolize the first sentence with, say, an S for sent, and the second one with an R for received to symbolize words like and or. People invented logical connectives so we could represent the way that bigger sentences can be built up out of smaller ones. All we need to put out two sentences together in a natural way is to use this symbol for and. With this system in place, linguistics can then use the well-understood properties of logic to think and talk about the less well-understood properties of language. Like take our now completed start together sentence. In logic, the whole sentences is true only when both halves are true. And since English seems to mostly work the same way, and the word and acts just like its logical cousin, we can suppose their meanings, their semantics are the same. And we can represent the semantics of logical connective with a truth table that describes it. So we can do the same for English. With this method, and English becomes just like our little logical truth monster, munching on truth and falsehood and spitting out the results according to the table. And we've managed to chip away a little bit at the semantics of natural languages using the cycle of logic. Since the words for words like or and if and not, as well, it could turn out that just by speaking a language, you know a lot more logic than you ever realized. Now, if we want to get the most out of using logic as a model for understanding natural human language, we need to tweak a bit. After all, language is more than just some letters strung together with a handful of symbols. We've got verbs and prepositions and tense and number and persons. Language is jam-packed. We need to get inside sentences too, and sensual logic just isn't up to the task. Thankfully, philosophers noticed this too. They saw its limitation and realized that, just like Aristotle's logic, there are some things that sensual logical can't do. Like take the fact that the following argument is definitely a valid one. None of Angel's friends hang out with vampire hunters. Connor hangs out with Holtz, and Holtz is a vampire hunter. So Connor is no friends of Angels. If we symbolize this using only the tools of sensual logic, we get this. But that argument doesn't hold up. None of the symbols even have anything to do with each other. Like, how do we get from an N and C and H to an F? Sensual logic treats sentences as indivisible atoms, and so it can't see what's going on inside the sentences. It has no way of relating the contents of these sentences to each other. So we need to crank up the power to deal with a problem like this. We need predicate logic. Predicate logic has all the tools of sensual logic, but it replaces the simple sentences we've using so far with something a bit more fine-grained. Predicates. Intuitively, predicates are like properties of things like green or immortal, but predicates can also be actions like bites or even states of being like is a vampire. Generally, predicates are the sorts of things that can be true or of something, like how Lorne is green or how Angel is vampire. So you can cut up the meaning within a sentence into deal chunk that fit together. To symbolize predicates, we use the same alphabet we were using before, but with some extra variables. We add the variables after the predicate, so it's easier to keep track of how many things are missing before the predicate can become a fully fledged sentence. So green could be jigs when the X let us know that it needs of thing to be green, and bites could be big C when the X says this predicate needs a bitter, and the Y tells us that something needs to get bitten. Unlike sentences in essential logic, thought predicates on their own can be true or false. If we want them to have some value, we have to apply them to something. To fill in those variables, so we introduce a few individuals into the mix, using lowercase letters like writing G to meaning Lorne is grey, or BDA for darling beats angels. Now both sentences are complete, at least, and they are both true. And since predicate logic otherwise works just like essential logic, we can stick the two sentences together, and so we can say Lorne is green and Darla beats angel. Is also true. Predicate logic is so powerful that it can fully capture almost every sentence we can think of, but we still need to cover the area that Aristotle had mastered with his logic, describing groups of individuals. That's because even though predicate logic is much more useful and much less ambiguous than Aristotle's, it still has no way to explicitly talk about collections of things. For that, we have to add one more pieces to our puzzle: quantifier. Quantifiers are the symbols that stand in for the words all and some, and historically we write them out with an upside down A and backwards E. Quantifier let us create all sorts of new sentences, like all of Angel's friends are good guys would look something like this, since that little arrow stands in for the phrase if then. This new quantified sentences literally means for all the things under discussions. If those things are friends of angels, then those things are also good guys. Clunky, but clear and unambiguous. And we can use quantifier to talk about smaller groups of things too. Like for the sentences, some vampire has a soul. We would get this literally translate back to plain English. This sentence means for at least one things under discussions that things is a vampire and that things has a soul. Again, it's hardly Shakespeare or even Joss Whedon, but it delivers the goods. And we quantifier in system predicate logic can even explain why the argument we brought up earlier actually works, even when essential logic made it look like it didn't. If it's true that none of Angel's friends hang out with vampire hunters, that Connor hang out with Holtz, and that Holtz is vampire hunter, predicate logic guarantees that Connor is no friends of angels. That's exactly what we not want. It might look like scary at first, but we can understand how predicate logic works for us here by thinking of it as being a kind of subtractions. The predicates O and H in the first and second lines cancel each other out, and we drop the quantifier because by the second line we've got replaced all of our variables with individuals, so we don't need them anymore. All that left over is negations and the sentence Connor is friends of angel. Put it together and we get Connor is no friend of angel. And never, if you haven't mastered predicate logic yet, the connections between the sentences are a lot more obvious here than they were with essential logic. So it's much easier to see where the conclusions comes from. It doesn't just pop magically into existence out of nowhere, and it's all because predicate logic lets us peek inside of our sentences to see what they are made of. Finally, just like how essential logic gave us the tools to understand connectives, predicate logic gives us what we need to start thinking about the meanings of other words. verbs and adjectives, and all these other predicates all have these logical meanings. And that means if we want to, we could build truth tables for our predicates too, just like with the connectives. So the meaning of a predicate like is vampire of fx, vx could just be a list of all the individuals that it could be possibly applied to, followed by true in all the cases where it does. So Angel is a vampire, but is not. Buffy is not. Neither is Cordelia, but Darla is, and etc. And if a phrase like is a vampire act enough, like its symbol version, we can suppose that the meaning of the phrases is the same sort of thing, a kind of truth table that pick out all the real world individuals the phrase applies to. This way, logic gets us closer and closer to understanding what speakers must know when they know the meanings of words. Of course, there's still more works to be done, since we haven't even come close to covering all the categories and concepts that you find across the world languages. But now then we are able to crack open our sentences and take a look at the pieces inside. Our investigation has become a lot more meaningful, so we've reached the end of the link space for this week. If you subtract out the right variables, you learn that sensual logic isn't powerful enough to describe a natural language like English. That predicate logic improves our understanding by breaking sentences up into pieces, adding variables and quantifier to the mix, and that with careful investigation, it could turn out that the semantics of logic offers greater insight into the semantic of natural language.